Welcome back to another YouTube video with Mr. Sandell. Lesson 2-5. We're talking about exponential and logarithmic chain rules. So we have more doubters that we're learning. Dinner is always a thing. You will always have to worry about dinner. I'm teaching you the doubters for exponential and logarithmic chain rules today. So our objective, quiet raise hand, who can read? Gio.
Apply the exponential and
Logarithmic.
chain rules to various problems.
Okay, so let's talk about the difference between powers and exponentials just as a little bit of review. So here are some examples. I'm just going to write one down. You can do some as well. This is something that I would consider a power house, 4x squared. This is an exponential house, 3 times 2 to the power of x. What do you see that is different? The exponent is the variable, whereas the variable down here is in the, what's that word that says down here? No, coefficient is the number in front. It starts with a B, 4-letter word. Let me give you some more examples.
Base.
Like base, there he is. So the variable's in the base for powers. The variable's in the exponent for exponentials, because that makes sense. Exponent, exponentials. So some other examples, make your own. So here's one that you might see on an AP test. 3 times x plus 2 to the power of -4. Or here's another one. -1/2, 2x to the power of 1/3. Make your own. You know what powers look like. They have an exponent in the base and then randomly have a power. They have to have some sort of power. Exponentials, you might have something even as hard as something like -2 times 5 to the power of 2x minus 1. That could be something that you will deal with. The inner is not just x. The inner here is 2x minus 1, which means your dinner won't be 1. Your dinner will be 2. Something that you might also see for exponentials, you might have like 1/2 e to the power of x to the power of 2, a giant tree of exponents. But the variable is still in the exponent, still in the power. The general form, I can do here in a different color. The general form here is you have some sort of coefficient, and then some sort of base, and then some sort of power. Again, you have some sort of coefficient, some sort of base. We'll just call that, how am I going to say this? I'll say like e. It's some number. You can't have a variable down there. To a power. The inner is blank, so you can think of that as the u if you want. U, that's the inner. But generally speaking, the inner is where the variable should be. So if you're thinking variable goes right here. The variable goes with the inner. That's what you're thinking of for general form. So far, so good?
Yes.
All right. Let's move on to actually doing the rule. So I'm gonna tell you the rule and then you're gonna apply it. That's kind of the way the AP works. I wish I could derive the rule. Why is this true? It's like the E house, the exponential chain rule, is like my favorite house. It's so cool, so beautiful. You look at a graph of e to the power of x, it's really cool. You look at the derivative for any x coordinate is exactly equal to its derivative. It's this really cool thing, but I'm boiling it down for you. And a e to the power of inner is equal to a e to the power of inner. That's really easy to memorize. It's the same thing. That's why it's beautiful. It's the same thing. That rarely happens in calculus. In fact, most of the time it's really, really ugly. The fact that we get something so simple, so concise, so beautiful, it makes me really cry with happiness. It's so beautiful, so easy to remember. And then don't forget dinner. Never forget your dinner. Good job. That's your doubter. I'm teaching you your doubter rules, but always be thinking, okay, don't forget your dinner. Never, ever forget your dinner. I'm just teaching you your doubter rules. You have now learned the doubter rule for E house. E house is the same. Derivative of E house is E house. Easy peasy, right?
So
all right.
For the next one, is it going to be 6e?
So let's first do doubter, right? Let's do doubter. What is the doubter of example 1?
2e.
Oh, wow, that's really hard, right? 2e to the power of 3x. It's the same exact thing, but here is where it's different. Now, first, before I do dinner, I want to talk about inner. What is the inner of E house? 3x. E house, the inner is always the exponent. So I know what the inner is. The inner is 3x, so someone aside from Claire, tell me dinner.
3.
There it is. And I now need to simplify stego. This simplifies to? Done. There it is. That's how you do an e-house problem. Let's try another one. Are there any questions on the first one before we move on to number 2? All right. Go ahead and do it by yourself. You should know this. You know how to do the doubter for e-house. It's really, really easy. Go ahead and do that now. All right. Give dinner a shot. Dinner is kind of hard on this one.
So is it going to be 1?
So what is the
Wait.
So inner is x squared, right?
2x.
2x. There it is. Inner is x squared, so dinner, or the derivative of x squared, is just 2x. So I have to multiply this by 2x. And then, of course, I need to simplify, so I'm just going to squish these all together. And that is going to be negative 2x e to the power of x squared, box it. Cool.
You want us to box in our homework, right?
Say again?
You want us to box our answers?
I only want you to box your answers if there's work that leads up to it. If you automatically skip right to the answer, you don't need to box it. That is the answer. But generally, you should be boxing your answers because you should be showing your work. All right, let's talk about the log house. The logarithm chain rule. So again, I'm only showing you the doubter here. Again, when I leave empty parentheses, I'm assuming that the u, or the inner, is going inside those parentheses. So just like up here, I had empty parentheses. This is where my inner is. The doubter for log house is, it's kind of tricky here. I got to remember it. It's going to be, if I have a coefficient, it's going to be a, the same coefficient, divided by the inner. A divided by the inner. And again, this is for natural log house, so if I call it log house, but I'm wondering if I should maybe change that now that we're going to be doing BC in here, because we are actually going to be doing a real log house instead of a natural log house. So maybe you want to preemptively say this is a natural logarithm chain rule. ln. This is all AB. BC is when you talk about the actual logarithm. So for now, we'll call it log house until otherwise. If you want to already start calling it natural log house, that's fine too. So A divided by the inner, and then you still have to do dinner. Good job. You guys are getting it. Okay, so this is times dinner. Don't ever forget your dinner. I'm only showing you the outer, or the doubter. All right, so let's see if we can do this one. Who can do it?
So it's 2 divided by 3.
So
Negative.
2 divided by the inner. There it is. Good job, Sego. 2 divided by x to the third. Arrow, you want to do dinner for us?
3x squared.
There it is, 3x squared. But we can simplify this. Claire, can you do the simplification for us? It's kind of cool.
X squared over x cubed, and then you can take out the x squared, so then 6x.
6 over x.
Yeah, 6 over x.
There, yeah, perfect. 6 over x. It's kind of a cool little simplification. It's weird to start with something so weird with logarithms, natural logarithms, and get a fraction. Yeah.
How you got to?
Yes, Claire, explain again.
Okay, so first you multiply 3x squared by 2 because whatever the top number is called.
And so you're going to cancel the
numerator.
x.
And so then it's 6x squared over x cubed, and since this is multiplication, you can simplify out the x squared.
So
on the
that's
top, the x squared completely disappears, and on the bottom, there's only
Okay.
one x left, so that's just 6 over x.
Yeah, as a review of how to simplify these things, I can think of 6x squared over x cubed as 6xx over xxx. X to the power of 3 is 3 x's. That's literally what it means, right?
Alright, yeah.
And then just cross out everything that's on the top and the bottom. I can cross out that one, that one, that one, that one. I'm left with 6 over x.
Okay, sounds good.
All right, slightly harder one, but not too much harder. Let's try example number 4. Do it by yourselves. I'll give you guys 30 seconds. Go. I always want to say choo-choo when we begin the video because it makes me feel like I'm wearing a conductor hat on a train. Anyway, so doubter. Sega, what is doubter?
-1 over 5x squared minus 3.
What is dinner, Claire? Geo, simplify.
negative 10x over 5x squared minus 3.
And Arrow, this is your question. Can I simplify any further?
No,
Why not? I have an x on the top and x on the bottom. Why can't I cross these out?
because they're not multiplication.
Exactly. You can only start canceling when things are being multiplied. This does not mean multiply. It is not being multiplied, so you can't cross them out. If it was a plus, it's still not being multiplied. I can't cancel it out. Good. That is our final answer. Box it. And that's the end of the notes. Any questions? Fist 5, how are you feeling on this lesson? How well do you understand the objective, the chain rule? I got a 4, 5. Is that a 4?
That's 3.
3, 3?
3.5.
and a 4. Okay, we'll see if we can improve those with the homework. Thank you, guys.